Thank you. I don't speak very loud, so if you cannot hear me, let me know. I'll try to make my best. I've modified slightly the title because they told me that you speak like this here. So if that's not correct, to talk to this gentleman here. First thing first, I work in InfluxData. It's a time series database. We're hiring. And so if you want to work with Kubernetes or with me, or not, let me know and I can show you around. Another thing that we've been doing in London, I run a few meetups in London. I run the Kubernetes London meetup, which is very large. And a lot of the meetups recently, I don't know why they decided that they were going to give away all these gifts to attendees. They've gone a little bit over the board, some of them, giving PlayStation 4s. We thought it was going to be the other way around. We're going to ask for money. So we're raising money for charity. We are now, I don't know how much we raised. Oh, wow. So, yeah, if you want to donate, it will be very nice of you. Otherwise, let's start with the journey, cloud native journey. How many of you know Kubernetes? Okay, a few. I have two versions of this talk, the very short one and the very long one. Let's see. So this is basically the cloud native journey that everybody that wants to go into Kubernetes has to endure, right? So the question that people ask is, shall I use Kubernetes? No. Thank you. So I did this in a conference and a gentleman stand up and left. He came for an answer, he got one, thank you and good night. Fair enough. So this is what happens, really. We go to internet and we see these people doing really cool stuff. You go to a conference like, wow, these people are managing software, like, wow. And then you try to do that at your work and something different happens. Like, just, why is not working? I don't know, but it should not happen. But it does. And I went to Cardiff to give this talk, so I had to put a whale there somehow to troll them, and that's why the slide is here. But Docker changed the industry. I think that there's no doubt about that. We'll talk about that. We will talk about monoliths and microservices. Monoliths wins, hands down, always. These are not my cats. I have a cat. I'm allergic to cats. This is not my cat. So the advice that I usually give to people is, look, if it works for you, do it. If it doesn't work, don't. And it's such a really good advice that you can do it for anything else. Like if you enjoy going to this restaurant, just go. If you don't. Right? It's like you don't like I have 2 children. Like you don't like hanging out with this guy, like this boy or this guy. Don't. You like it, just do it. See, it works. The other thing I usually see people tripping is Kubernetes is an eventual consistent system. And eventual doesn't mean now, it doesn't mean this, and doesn't mean always. And you have to be okay with that. You have to embrace not knowing. It's like when your children grow up, I have one at 17, and then go out and they don't come back when they're supposed to come back. You have to be okay with that. That is just part of life. Everything will be okay at some point, hopefully. So this is the cartoon. Let me take this thing off. I usually peel my t-shirt. I brought a few. So what we do in Kubernetes is something more like that. So that we define, they said that this is what we would like to have, and then things will try to converge. And that's something that a lot of people do not feel comfortable with, right? So then the real question is, what is Kubernetes? So all the guys who raise your hand, who is using Kubernetes now? Okay, what is Kubernetes?
It's a way of declaring resources against an
Aware of the current resources, yes. You were using Kubernetes as well, right? I showed you, like, what is Kubernetes?
I would say roughly the same thing, but then I work.
Okay, same, like who else? You work with Kubernetes. What is Kubernetes?
It's a container orchestration.
Container orchestration, yes. All these things are correct, but I like to define Kubernetes slightly different. And what I say is that Kubernetes is an API. It's an API that abstracts our infrastructure, right? And this is a very powerful message, that if you stop thinking about containers and orchestration and you start thinking about APIs, things get slightly easier, right? So this is Kubernetes. We have an API, we have state, and we have compute. That's it. Right? You can see it like that. Like well, yeah, it's just applications, APIs, that blah blah blah, and machines, right? Word of caution here. Like the API has dimension. It's not just one line on the sun. It has dimensions and it has failures. It has holes, right? There's like this thing that, yeah, in theory the interface it is. Well, this is marketing, right? Like this is what we show that the product does. But in reality, we have a few, issues that we will deal at some point, and that's important to understand that, right? Because then we will go and try to do things because we have problems in the APIs. So with Kubernetes now, we can define an API to run our business, because it's not just an API that abstracts my infrastructure, right? Like the difference between all the systems and Kubernetes is we have now two contracts. We have a contract which is Docker, which is contract between my application and my machine. Now I can run my application in any machine. The only thing that the machine has to do is to run Docker, right? I used to do Java, a lot of Java, and Java has a similar concept. It's the JVM. Right? You can run all these applications and then put them in the JVM. Can you run two JVMs in the same machine? Not easily, right? So then things like, you are a Java developer, your boss comes like, can you test this that we're doing in 1.8 and 1.9? Yeah, I need to find a new machine and set up all these things. Docker goes and so like, well, I change this line, Docker build, Docker run, fail. Or not, right? But that's the advantage of it. Like we have a contract between machine and application dependencies. Right? This is very important. Now we have another contract, which is Kubernetes, that allows us to abstract all the infrastructure. How do my application consumes storage? Well, we have now an API for that. Like you don't have to worry. We will see an example. You don't have to worry about the ins and outs, like the plumbing, about how things end up there. You have an interface. You can consume the API. You're good to go. You don't have the API. You cannot do it. Right? It's that simple. So Kelsey Hightower said this very recently, like 2 days ago, right? And this is something that I've been saying for a while, that Kubernetes will become invisible. Kubernetes will disappear because Kubernetes is just the API. What we're going to do is to build our business on top of that. That's what it makes money. Unless you're a cloud provider, this doesn't make much money. So remember, we have an API. It's a REST API, right? Like that's the whole core of Kubernetes is a REST API. REST API deals with objects. How many of you have been written an API, a REST API? Yeah. What do? You receive objects and then you do things with these objects, right? Yeah, that's why we have all the YAML. Because what YAML is the object representation that we're sending to the API. Why is it so freaking complex? Because we don't have proper business abstractions. And we could spend the whole night talking about that. But it's one of the problems that the YAML that the API server consumes and the YAML that we should be creating should be two different things. It's up to us to create this intermediate layer that almost nobody does. Like that, this is the business layer. Like let's simplify how I, as an influx, create my objects. That's why we have Helm and Compose and all the other systems to manage YAML, write YAML, programming YAML. So I like this concept of the API because then we can talk about being above the API and being under the API, and then the simplification that this vision brings into our managing teams and managing infrastructure and applications, right? The other thing that Kubernetes brought was composition, and composition is really powerful. Right now we have a way of describing the application. We have an object to define the runtime. We have an object to define secrets, egress, update, how to scale my application. Now this is part of my application. It's not that, oh, these guys have written something in Puppet that's going to do this, or someone has written another batch script that does that. Now we have an object that describes exactly how you want the application to behave. Good. So why Kubernetes? Well, it had clear interface. We were talking just before about the different orchestrators and the different systems to run containers, and say, well, why Kubernetes? Well, it does. Like, it has clear interfaces. It's for clear primitives. If someone knows what is this, please tell me, because I found the image. Nobody, and I've shown this image in all my talks, nobody has seen this ever. We don't know what it is, but it is extremely weird. I think that we all agree. We have like consensus. Everybody agrees. Let's leave it. We are based in building simple implementations. We use the controller pattern. Right? It's the same thing that the Unix is built on, like do one thing and do it well. Right? And this aggregation of controllers under one function will provide a business value. Building these things using this pattern is extremely powerful, especially if you have a diverse team of people who know many different things. I'll show you an example later of a health operator that we have been designing that is basically based in this pattern and why. So let's look at an application, right? Let's a stateful, like proper stateful application that we want to run that has data, like proper applications with data. Kafka or something worse, right? So this is what we're going to see. It's me, right? Saying like, well, I'm thirsty. I'm declaring the state. I'm thirsty. Can I have a beer? And then Glenn, who used to work with me, said just leave it with me. Right? So I'm the pot. Glenn is the PVC, and the beer is the PV. Right? We have all these objects. Like this is my volume. Yeah. And this is the object that basically will make sure that the volume ends up in my application, in me, right? Last time I gave this talk, it was in Cardiff, and Louis was there, and Louis runs the CNCF in Cardiff, and he drinks all my beer all the time. So this error will be very common in Kubernetes. You will be very familiar. Is this thing can happen? Why it happens? Many different reasons, but so now it doesn't work. This is the application, right? Above the API, under the API. Yeah. Let's think about what we used to do. We had an application, and the application will need a disk, right? Now, a disk has to be attached to the machine. We have to format it, and we have to mount it. If you were around when we started with Kubernetes, we had plugins, and it was just very complex. Why? Because all these things are very different. Trying to create an abstraction or an implementation that solves all the cases became really, really difficult. So what did we do? We defined something called the storage class, and the storage class is basically where you define your controller that is in charge of doing these little tasks. So now we have a way of expanding and allowing people to do whatever you want to do. So if you have a very weird storage system, you can write your own storage class, which is basically a piece of code that will run, that will get you storage into your machine. Awesome. What happens at the application level? Well, I have my application defined there, and then I have my volume defined as an object, and we can say, you don't have access to the storage class. You cannot consume it. So you cannot do this until the team that is in charge of building these things says, hey, we finally have the local provisioner. Now you can go and consume local data in a safe way. Right? And then it's basically that in essence. People write YAML or write Bash, and they argue all the time. So is Kubernetes complex? Yes, it is complex. Because there's a lot of things that can go wrong in series or parallel. But it is true that you can build very complex solutions using very simple implementations. This is a multi-cloud solution. And in essence, it's just getting traffic from a global load balancer and sending them into a cluster and then just sorting it out, right? The key here is to understand two things. One is like there are things that we control. There are things that we might not control. The context is something that we might not control. You have to be aware of this. So when I was in Sky, for example, they had this thing that they wanted to build a new data center in less than 24 hours. 24 hours? Why 24 hours? And it was because they were running a Jenkins job, that it was a sequence of steps. And things could go wrong, and then things that you have to wait, because now we try to install this database and it failed. Now we have to basically undo it and try it again. So in Kubernetes, we don't do that. In Kubernetes, what we do is to check everything into the cluster and let it converge, right? So you will send all these things there, and what will happen is that we have the readiness and the liveness probe. That what this does is to check. Readiness probe basically check dependencies. So each component will check their own dependencies and make sure that if, they are green, then I can do what I have to do. So this one, for example, is a job that populates a database. What this job does is to check if the database is on. If it's not on, the job crashes and say, oh, I cannot do it, right? You have to be comfortable with that. It's okay. The cluster will basically reschedule this job and try it again and again until the database goes green, and then it runs, and I have my data, right? Then the other guy will go and check if the database is on, and boom. And now finally, because all the things go green, we can have public traffic, right? The key here is to understand that this guy only has to worry about these two dependencies. Right? That this is the important thing. The Sky model is, well, I have a very clear sequence of steps. I will start with this one, then I will run this one, then I will make sure that this one can talk to this one, and then I will run the other one, and blah, blah, blah. Now we don't have to. We can compact. Why? Because we have an API that is exposing certain things that allow us to do this. If you take something from this talk, is just sort out your upgrade story with Kubernetes. First thing you do. If you cannot upgrade your cluster, you're dead. You don't know it, but you're dead. 2 companies have called me because I told them first thing is like you have to sort out your upgrade, and now we're okay. We just create a cluster until the certificate expired and the cluster went down. So can you come and help us? So you just have to renew the certificates. But I told you to sort it out, right? So this is the DevOps engineer. This is the project manager. It happens. Anyway, my name is Ivan Pedrazas. I've been working with this for a while. I do collect typewriters by accident, but I do. And I run meetups. I think I said that already. So, okay, we went from having these wonderful APIs now like GitOps. What is this GitOps thing? What is all this thing about, right? So I'm from Barcelona, and I was one day at work, and someone made the comment as, oh, he's such a Git. I didn't know that Git meant something in English. It does. But for me, it's like, you calling someone Git? What are you trying to say? Yeah, I was very confused, but hey. So what is a pull request? And at the end, it was like, can you please squash your comments? No. So what is the difference between using things like GitOps and using other things? Right? At the end of the day, it's about running my applications. Why GitOps is getting this trend? And the answer is, it simplifies one of the biggest issues that we have, which is knowing what's happening and having this source of truth and removing friction. Right? So what happens in GitOps is that you define what you would like to run in the cluster in Git. And then you have automation that goes to that cluster and runs it, right? I just realized that this slide should come later, but what we do is to basically write software and push it to a Docker registry. And this is the GitOps bit that we have a different repo where you define, I want to run these applications, and then we have some automation that will go and fetch the artifacts and run it. And testing becomes very interesting because one of the issues that testing is creating environments and testing different combinations of things, right? So this is basically GitOps. GitOps is about defining deployments and operations that you could do. I need to change this, or I need to modify that in Git, right? It's pushing the management of the infrastructure and the applications to Git. You can use GitHub organizations, you can use your reviews, your approvals. Things get much more control. What else happens is that because everything is in Git, this hero culture that we used to have in operations is basically fading away. Because now there's no, I have a magic script that sorts out the problem. You have a magic script that has to come to Git. And then we all see that, oh, you just are doing these 3 commands. There's not much magic here. It's just that you didn't want to share the knowledge. So all these things that we used to have now change, right? Like handovers. How is this guy managing all this? Well, you can go now and read it, right? It simplifies operations a lot. How we evolve from not having anything to having Jenkins, to having Kubernetes and then GitOps, right? Like what you can see is this trend. What we're trying to do is automating managing applications. So basically what we do is to compare the current state with the desired state. We can have rollbacks, we have version controls, and we have 2 repos, one for the code and one for the configuration. CI and CD. I put this image because I was building these slides and my daughter was there and she really was surprised that the piggy was eating sweeties like a mint. And I said, yeah, because the fact that there's a dog behind, but the fact that you have a pig in your bed, it is okay. She was shocked that the pig was eating like, yeah, very cute. So I thought, okay, I'll put it in my slides. So one other thing that happens now is that we start separating CI and CD. CI and CD is not a very mature technology thing, right? Now we are separating finally, and we have CI and we have CD. Right? CI is about the artifact lifecycle, like writing code, building an artifact, testing it, putting it on the shelf. CD is about application lifecycle. It's about managing applications. You can see CD as a dependency management problem, right? You can look at any kind of language as Java or Maven to manage dependencies, Go. In Go, we have many. I don't know why we cannot agree on what is the way of managing dependencies, but we keep just building new solutions. Or Python, Java, all these languages have a way of managing dependencies, right? And what happens? You modify the dependency, and then your code might or might not compile. Or if it compiles, it might or might not pass the test, right? Same thing happens when you modify the dependencies in your application. You have a new version of this application, and guess what? You cannot deploy it because it crashes. Or it can deploy it, but then the test that you run fails, right? So it's about the same kind of issue that we have, dependency management, right? People spend a lot of time thinking about automation. The automation, to me, is not the issue. The issue you will have is all the processes you have to have on top. How to promote environments, for example, right? So what are the challenges that you will have? You will have pushback. If you want to put GitOps in your company, you will have pushback from everybody until they realize that actually what you're doing is making the life easier. It will take a while. How do you implement this? Well, the technical that we use is basically to have people becoming the human APIs until you have time to build it. Right? That when we move all the stuff that we had in my previous company, into GitOps, we were lacking all the automation, but we started building it. We used to basically, when someone was deploying something, we were like basically doing a pull request and merge. What we will do is to get a Slack notification and go and do it manually until we basically manage to build the automation, right? So you always will find, hopefully, the way of getting there. This is the most tricky bit that you will face, how to promote your environments. Because this bit here will illustrate like the table that I put before about runtime and configuration and context. You will have configuration in objects that belong to a different artifact. Right? Like you have the hierarchy, you have to decide cloud provider, environment, production, UAT, test, development, clusters, right? Each company has a different hierarchy. Objects come and go and people move them. You have to find the right place to put the different artifacts, right? Okay, operators. Who knows what an operator is? Okay, what is an operator? Oh, God. I mean, it's only 3 people.
The controller that responds, like, and if you shove a resource, custom resource into Kubernetes, the operator observes the declaration of that resource and tries to inactivate the requirements and make it so.
Do you agree?
Custom controller.
Custom controller. Yeah, an operator is basically a piece of code that we write that tries to do something, right? And it's like the name of the operator is because it tries to replace a human operator. Like when you have a database and these nurses that we need, called sysadmins to basically, or DBAs to run the databases. So we want to abstract them, right? And people just start writing all these operators, and then people like Marcus complain, why the quality is so bad? Why is it? Because, as we said, we see that we have all these APIs, and people start writing the APIs and then may or may not work for you and abandon the idea or not, right? So when you write an operator, the key here is to understand a few things like who is going to use it, how it's going to be used, why you're going to use it, and when it's time to stop using it. So this is the bit that I was talking before. This is a health operator, and the health operator is basically this. And this bit has been designed with a lot of components that move around. Why do we have this? Because now we have people who don't know Go but know Python, and they can contribute to this, because what we want to do is basically to check if a service is created in the cluster, and if it's created in the cluster, we want to create a health check. Or we want to control certain changes in the pods, or we want to control certain things that happens that you want to implement. So you have the ability to write a monolith, or you have the ability to define these little controls, and then you will need the operator that sits on top, so that orchestrates the whole thing, right? This is very powerful, and it's very simple to build, because what you're doing here is writing not even 300 lines of code, right? Testing one component in isolation is much easier than testing a whole bit. And so why Mark was asking this? Because the majority of people are focusing in the wrong question, right? Who is going to use this and how you're going to maintain it? Like, it's not just about the functionality, it's about the operability of a solution. So I always finish my talks. We always finish my talk putting these checklists, but then the guys from Learn Kates, they created this checklist. I think that I have a link here. And this checklist is basically something very similar to what I have in my slides, but they have much more meat. So I think that, as I said before, you have to know when to stop doing it, right? This bit. So I think it's time for me to retire my checklist. Anyway, thank you very much. Questions? No questions, perfect.
So I was really interested in you saying about you have to give repos for your binaries and your configuration.
So the question is about managing applications that are tightly coupled or not tightly coupled and having two different repos and how to organize that, right? So remember what they said. CI is about artifact lifecycle. It's about writing code, creating the artifact, testing it, and then putting it on a shelf. That's it. Then you have the other part, which is the other repo, that is where you define all these dependencies. So, okay, I want to test in this environment if these three applications work well together, right? And then you will have automation that will get these applications and deploy them in the cluster. It can happen that they don't work well together because whatever reason, right? But the issue is usually going back to the artifact. You have two artifacts. You have the runtime, the Docker container, and you have the deployment script, right? Like the Helm chart or the JSON or the compose or whatever thing that you are using to basically declare how to deploy your application, right? So you have these two artifacts that you always have to think about. Applications is not just one jar or one ER file. It's not like that anymore. We have what do we want to run and how we want to configure it, right? And then the context is where it runs. You can achieve a lot, but it depends on how you decide to manage your artifacts and how do you define the dependency mappings and the automation, right? Am I answering your question? Okay. Usually what you're describing is that you haven't sorted yet the split of the artifacts. You are considering the deployment scripts, the Helm chart or the whatever, which what do you use? Well, Helm or Customize, you have these YAML files and then you have your Docker container and you are assuming that this is one thing and that is not right. And then when you have one monorepo, what happens is that you multiply that for a lot of things, and then you have the constraint of having one single monorepo that it's bringing you all these things, right? And then you don't have an easy way of simplifying. I just want to deploy these three applications or these three microservices in isolation to test some sort of thing. Like probably you don't have the ability to do this. Your system is not flexible enough, right? So you have to think about, okay, let's step back, let's create the artifact in a different way and have these other branches or these other Git repos that allows me to do certain things that otherwise I could not do. It is about which artifacts are you going to use in your deployment scripts to be deployed in the cloud, like what for the automation to consume. Yeah, we can talk about it if you want. Any more questions?